a subject that's near and dear to my heart, simplifying square roots. It really kind of bothers me that so many students hate fractions and square roots, and they prefer decimals because honestly, there's no precision in decimals like there is in square roots and in fractions. So anyway, on this one, how do we simplify these things? And I think a lot of people just say, all right, well, I'm going to just take the square root of 96, and I'll just go here and say the square root of 96. And I know that, by the way, it's going to be between the numbers 9 and 10, right? Because 9 times 9 is 81, and 10 times 10 is 100. So it's going to be somewhere 9 point something, and it's 9.79, and it goes on forever, and this appears to be irrational, and it's like not repeating, and it's not terminating, and etc. So it's kind of a pain. But what do we actually do here to simplify these, and why would we want to simplify these? Well, what if I ended up saying that it ended up being, well, it doesn't matter. So we'll get into that in a second. We'll talk about why it's important in a second. But first of all, we'll just start with, what do we do here? Well, I want to factor this. That means, and if you think about this, we factored a bunch of different things, and there's a bunch of different ways to factor. But this way means we're going to take this big block of ice. If you remember that analogy I've been using all year, we're going to take this big block of ice in a bag, and we're just going to break it up into all of its smallest parts. So how do I break up 96? Well, I like to go in order from the smallest to biggest, and 1 doesn't matter. We know that 1 goes into any number. So I'm going to start with 2. Does 2 go into 96? It does, because it's even. So 2 times 48 is going to equal 96. And now this is going to be one of the smallest. This 2 is going to be one of the smallest ways that I can make a piece of 96. But I have this other big chunk, right, that I can break up. And again, I can break it. And you could say 6 and 8 if you want, but again, I prefer personally to go in order. So I have this other 2 that's as small as it's going to be. But this 24 isn't as small as I can get it yet. I can break this up again to a 2 and a 12. And again, now this 2 isn't going to get any smaller, but this 12 can if I get a 2 and a 6. And this 6 will break up into a 2 and a 3. So I have 1, 2, 3, 4, 5 2s, and 1 3. And now think about this. We're saying square roots. Well, hopefully we all know that if I rewrite this as the square root of 2 times the square root of 2 times the square root of 2 times the square root of 2, and again, I have 5 of these things, right? And then I have a 3. I hope we all know that the square root of 2 times the square root of 2 actually equals 2. And the square root of 2 times the square root of 2 actually equals 2. And here, this is sad. It's like all over in high school. No one to go out with. You got to stay home. So I have a square root of 2 and a square root of 3. They don't have a partner to hang out with. So I'm going to get 4 times the square root of 2 times the square root of 3. Well, it does turn out that these, even though they have to stay home, that they can at least hang out together. So we're going to get 4 times the square root of 6. So the question is, what happens if I take the square root of 96 and if I take 4 times the square root of 6? They equal each other. So this is what's known as simplifying square roots. I know that 4 times the square root of 6 equals the square root of 96. Now, I think a good question would be, who cares? Like, why are we going through all this process? Well, again, this has to do with making things smaller. So let's pretend I had a problem that said the square root of 96 divided by 4. Well, if we didn't know any better, we would leave it like this. But because we know that the square root of 96 equals 4 times the square root of 6, we can now just simplify the whole thing into a 6, if that makes sense. So that's really what we're doing today, is we're just chipping these numbers down into a smaller, more manageable size. So let me kind of pause this and set this. So again, what I would do on this is I would just say, here's how I would solve this one. And I know I already did this one, so I'm going to keep this one brief. I would say square root 2 times 2, 3, 4, 5 times 3, and I would say that's a 2, and that's a 2, and 2 times 2 is 4, and those ones stay inside, and I get a 6. Literally that easy. I wouldn't try and overcomplicate this at all. So here, 2 and 108, 2 and 54, 2 and 27. Now 2 doesn't go in anymore, but I know 3 does. And again, this is a nice little trick for 3. 2 plus 7 is 9, and 3 goes into 9. That means 3 goes into 27. So hopefully we agree, right? 3 times 3 is 9, 9 times 3 is 27, 27 times 2 is 54, 2 times 54 is 108, 2 times 108 is 216. That's this whole thing. So I know that this is the same as 1, 2, 3 2s and 1, 2, 3 3s. And again, these 2s and these 3s, 2 times 3 is 6. These ones have to stay inside, and 2 times 3 is 6. So I expect that if I get the square root of 216, it will equal whatever 6 times the square root of 6 is. So they equal the same amount. So this would be my simplified version right here. And again, this works sort of for all of them. What happens if I get a number like, I guess let's start with this one real quick. So here I'm going to get 2 and 72, 2 and 36, 2 and 18, 2 and 9, and 3 and 3. And some of you guys may have already realized, like, what are you doing right now? Why are you going to so much trouble? Because I want to show you something. Here, 2 times 2 is 2, 2 times 2 is 2, 3 times 3 is 3, 2 times 2 is 4, times 3 is 12. That's known as a perfect square. Hopefully you already knew that the square root of 144 was 12, right? But you can still go through the process. So if you see the shortcut, take the shortcut. Just go straight to 12. If you don't, you should get the correct answer even if you go the long way. So what do I do with these ones? So here, 2 doesn't go in, 3 goes in 15 times, 3 goes in 5 times. So I'm going to get 5 times the square root of 3 times 3 times 5. Like, this 5 doesn't go away. Well, these can leave, and this can't. So I'm going to get 5 times 3 times the square root of 5, right? That pair of 3 comes out, so I get 15 times the square root of 5. And again, if I look over here, you can see that if I go 5 times the square root of 45, it's going to equal the same thing as 15 times the square root of 5. And don't forget, the whole reason we're doing this is simplifying them allows me to sort of simplify these easier, right? I can like divide later if I need to or whatever. Some of these look like pretty big numbers, but again, not a big deal. I don't know, I guess I'll do one of the big ones just to show that I'm not afraid of it. So I know that 1764 is going to divide by 2. It's going to go in, I don't know, 882 times. Now that's going to be 2 and 441. I know 2 doesn't go in, but think about this. Like I said in that other shortcut, 4 plus 4 plus 1 is 9. So I know that 3 goes into 9, so 3 has to go into 441, which is a nice little trick. So it goes in 147 times. And again, 1 plus 4 is 5, 5 plus 7 is 12. So I know that 3 will go into 147. It looks like it will go in 49 times. And I know this will be 7 times 7. So there we go. I get 12 times 1, 2 2s, 2 3s. So this is a prime number. This is kind of crazy. So 2 times 3 times 7, 12 times 2 times 3 times 7 is going to equal 12 times 42. So I didn't realize this, but the square root of 1764 must be 42. So kind of cool, right? And then obviously I need to finish that up by multiplying by 12, and I get 504. So this whole thing's simplified as 504. But you can see how cool that was to sort of break this whole thing up right here and discover that it actually equals 42. So like on this one, no big deal. If you can see the shortcut, the square root of 36 is 6, so 2 times 6 is 12. Or if you didn't see that, you know, maybe you would say 2, 18, 2, 9, 3, and 3, and you would get 2 times the square root of 2 times 2 times 3 times 3, which would be 2 times 2 times 3, which is 2, 4, 12. Right? So either way, you get the shortcuts or you don't. So that, in a nutshell, is simplifying square roots.